Okay, we're going to try and prove that OF squared is equal to AD times DE divided by 4. And man, when you first look at it, you go, well, that looks pretty impossible because it's just too weird. And it actually isn't so as hard as it seems at first, because you always use the similarity from the last question. You know that ADB was similar to triangle BDE. Write it down, because you can look and see AD goes with BD and DB goes with DE. So we're almost certainly going to use those ratios somehow. And what's the story with this OF? Remember right in the beginning I said, oh, that's a midpoint and that's a midpoint. Now, do you remember from grade 10? Boy, if you did, you could use proportionality and show this is 1 to 1. But you know what? The midpoint theorem says that if you join the midpoints of a triangle like this, what it does is it makes this OF 1/2 as much as DB. That's called the midpoint theorem. This is going to be twice as long as this if you join the midpoints of a triangle. Now take a look at this. F and O are the midpoint of AD and AB. Well, that's the big secret. Now let's take a look at the first thing. Remember I said AD goes with BD, DB goes with DE. Then we just cross multiply. Oh, look, we get BD squared is AD times DE. Now there we go. Look at that. We're trying to get AD and DE. But hang on here. BD is twice as big as OF. So BD equals 2 times OF. What if we square BD? BD squared would be 2 times 2, 4 OF squared. Well, 4 OF squared, if it equals BD squared, I can replace BD squared with this. 4 OF squared equals AD times DE. Gee, we almost have it. Divide both sides by 4, and there's your answer. Now, yeah, you can follow it. Maybe it's a little bit tricky. It's one of the harder questions. And there you go. That's the last one.